Alright, in this screencast we're going to learn how to solve quadratic equations by a technique called completing the square. And to start off with, let's look at this example right here, which is actually pretty simple. I already have a perfect square here, so all I need to do to solve this equation is take the square to both sides. So I'm going to go the square root of x minus 2 squared equals, and since I'm putting the square root into the problem, I have to remember to do plus or minus. Okay, now the square root of x minus 2 squared is x minus 2, and the square root of 8 reduces to plus or minus 2 root 2. So when we solve for x, we just add 2 to both sides, and we get 2 plus or minus 2 root 2. So we get two answers, 2 plus 2 root 2 and 2 minus 2 root 2. So what does that have to do with completing the square? Well, completing the square is a technique that forces the left side of the equation to be a perfect trinomial square. And these are the steps we're going to use to do it. So if I have an equation in the form of ax squared plus bx plus c equals 0, notice it has to be equal to 0, okay? Then I'm going to make sure the lead coefficient is 1, so that means a has to equal 1 before you start. I'm going to move c over to the other side by subtracting it or adding it, whatever is necessary. Then, this is the most important part, I'm going to take half of the x coefficient, I'm going to square it, and I'm going to add it to both sides. Okay? Don't forget to add it to both sides. Once we do that, we have created a trinomial square that is easy to factor. Okay, so we're going to factor the left side, then we take the square to both sides, and we've got our answer. Let's try it with an example. So we're going to solve x squared plus 8x minus 3 equals 0. My lead coefficient is 1. So I'm going to add 3 to both sides to get the constant on the other side. Now I'm going to take half the coefficient of the x term, which is 4, square it, that'll give me 16, add it to both sides. So that's x squared plus 8x plus, I'm going to write it out, okay, 8 over 2 squared. Half the coefficient of the x term, square it, add it to both sides. Okay, so I get x squared plus 8x plus 16 equals 3 plus 16, which is 19. Alright, so this is now a trinomial square. This factors into x plus 4 squared. And then I just take the square to both sides. Don't forget your plus or minus. And our answer is x equals negative 4 plus the square root of 19 and negative 4 minus the square root of 19. Well, what do we do if the lead coefficient isn't 1? Well, we just make it 1 by dividing everything by the lead coefficient. So I get 1x squared minus 4x plus 13 thirds equals 0. And we just proceed like normal. So I have x squared minus 4x. I'm going to subtract that constant. I'm going to take half the middle coefficient. So half of 4 is 2. Squared is 4. Okay, so this is negative 13 thirds, and getting a common denominator, 4 becomes 12 thirds, and I get negative 1 third. Okay, over here, this is a trinomial square. It factors into x minus 2 squared. Over here, I have negative 1 third. Take the square to both sides. X minus 2 equals plus or minus the square root of negative 1 third. Now we're taking the square root of a negative number, which means it's going to be plus or minus I over root 3. Rationalizing that denominator, that's I root 3 over 3. So, final answer, I'm going to add 2 to both sides. X equals 2 plus or minus I root 3 over 3. So we have two complex roots that happen to be conjugates of each other. And that's how you use completing the square to solve a quadratic equation.